In this video, we're going to have a look at what half equations are and have a look at how to write and balance half equations. So we talk a lot about redox. This whole topic's called redox. Now redox stands for reduction oxidation. Our whole equation is a redox reaction because reduction and oxidation always happen together, and our whole equation can be split into two half equations, one representing the oxidation reaction where electrons are lost, and a second half equation where representing a reduction reaction where electrons are gained. Now, I'm going to show you this video in a second, and this is a video of the thermite reaction. Now, some of you might have seen thermite before. It's how we join railway sleepers together. It's a very useful reaction because it produces molten iron. So let's have a look at what's going on. So we start off with iron oxide, so Fe2O3, okay, which is a solid. And we combine it with 2 lots of aluminium powder, which is also a solid, and they react together in what you'll see is a very exothermic reaction, and we get aluminium oxide, and we get 2 lots of Fe, which is a solid. Well, it's a liquid when it's produced, but it falls into a nice bucket of sand and water to get it to turn into a solid. So let's have a look at the reaction first of all. So Jay and I actually set this up and recorded it for you. So there's a sparkler at the start that we use just to ignite the whole thing, and the sparkler then ignites. We've got a tiny little bit of magnesium powder on the top just to get it nice and hot, and then the iron, and then it is just a mixture of iron oxide powder and aluminium powder. And if you get it nice and hot, it will just explode, as you saw, and produce little lumps of, well, molten iron, but it cools right down in the water, and if you tip it out you can put a magnet in there and get tiny little balls of iron. So let's have a look at splitting this into the half equations. The first thing we need to do though is turn it into the ionic equation. Now if you remember, when we do the ionic equation, it's where we remove the spectator ions. So I'm hoping you should be able to see that the oxide part is actually spectating in this reaction. The oxide stays as ionic oxide and isn't really part of the reaction. So we can break this into the ionic equation, which would be that we have 2Fe3 plus 2Al, and it turns into 2Al3 plus 2 lots of Fe. Now, then we should be able to break this into the two half equations. So let's start off. I'll use red to show that we're doing this as half equations. So if we look at the iron, and now I can ignore the 2's here because it's what I can see is we've got Fe3 plus is turning into Fe. Now to do that, we need to look at this and go, if it's starting off as iron 3 plus and it's turning into iron, then to do that it must gain 3 electrons. Okay, so if something gains electrons, then thinking about oil rig, oxidation is loss, reduction is gain, so this must be reduction. Okay, now let's have a look at the other half equation. Here we've got aluminium is turning into aluminium 3 plus. Now to do that, the aluminium must have to lose 3 electrons. So we write them on the other side, and we can see how this is redox and how it works because, well, let's just fill this in first. So this must therefore is losing electrons. It must be oxidation. And the electrons that are being produced by the aluminium reaction go into making the reduction reaction. This is why redox only happens, the reduction and the oxidation have to happen hand in hand. They are two halves of the same reaction. Because the electrons that the oxidation reaction produces go into feeding the reduction reaction to make sure that it happens. So you need to be able to write and balance half equations. So we're going to start off with some simple example, a bit like the ones you saw on the previous page. So if I considered, say, copper 2 plus turning into copper, so copper ions turning into solid copper, to get here, we would need to add 2 electrons to the copper. This is because we need to make sure that the charges balance on both sides. So if I've got 2 positives, I've got to add 2 negatives to make the neutral copper. So I make sure that my charges balance on both sides. Now I'm going to get rid of that, and we'll have a look at some slightly more complicated examples, because most the half equations you will have already seen are fairly straightforward like that, but there are some more complicated examples where we're dealing with polyatomic ions, so ions that have got more things in them than just being a simple ion. So if we consider the manganate ion, MnO4 minus, and manganate can react and become manganese 2 plus. So we need to consider how we would go about balancing this half equation. So there are some rules we need to follow. So the first step in doing this is to work out the oxidation state of the main species. So the main species here is clearly the manganese. So if we work out what its oxidation state is on the left-hand side, we can see that we've got 4 oxygens, and that would add up to -8, but it's got to add up to minus, so it'd be +7, and we need to, the other side would be simply +2. So we can see that our oxidation state is reducing because we're going from +7 to +2, and therefore we're going to need 5 electrons to be gained in this reaction. So we can see it's reduction because our oxidation state has decreased, and we can see it's been reduced by 5, therefore it must be 5 electrons are gained. Now the next step is to do something about these oxygens in the manganate. So I've got 4 oxygens on this side, but at the moment I don't have any oxygens on the right hand side. Now the only way I can get rid of those oxygens and to put them on the other side is to add them as water. So if I add 4 molecules of water on the right hand side, that will balance the oxygens, but then I get another problem, because by adding 4 molecules of water I get 8 hydrogen atoms on the right hand side that I don't have on the left hand side. So to get rid of those, the only thing I can balance those with is with hydrogen ions, so H plus ions. So I didn't leave myself enough space, so I have to put them right at the start. So if I add 8 hydrogen ions at the start, then I'll end up with 8 hydrogen ions plus the manganate plus 5 electrons would turn into manganese 2 plus 4 water molecules. And you can see that this now appears, all the species are balanced, and we've got the electrons in there. So if I want to double check I've done it correctly, what I need to do is add up the charges and make sure that the charges on both sides balance. So I've got 8 positives in the H pluses, and then I've got 1 minus in the manganate and another 5 electrons, so that's 6 minuses, so 8 pluses and 6 minuses adds up to 2 plus. And on the right hand side I've got manganese 2 plus and 4 neutral waters, so it's 2 plus. So both sides add up in total to 2 plus, and my charges balance, so I know I've added the right number of electrons. So this would be a good point to recap some of those key points on how to do the balancing of the half equations. So one of the first things you need to do is remember to balance the number of atoms that are in the main species. So in this one we checked that there was 1 manganese on both sides. Step 2 was looking at using the oxidation states of the main species to check whether it's oxidation or reduction, and also to work out how many electrons have been lost or gained. Step 3, you need to balance the other atoms. So starting off with the oxygens, you balance any oxygens by adding water on the opposite side. So balance oxygens with water molecules. And then step 4, balancing with water is going to give you some extra hydrogens, so you need to go back and balance any of those hydrogens with H pluses, so hydrogen ions. And then to finish the whole thing off, you need to check the number of charges, so that the total charge on the left-hand side is the same as the total charge on the right-hand side. And in doing that, you can make sure that the whole thing is completely balanced and finished. Okay, I think it's time for you guys to have a go at doing one. So I'm going to give you an example using chromium. And then I want you to press pause and have a go before I go through the answer. So we're going to look at chromium 3 plus turning into the dichromate ion. So I would like you to press pause, and then I'll go through the answer after you've had a little bit of time to think about it. Okay, so you should have had time to press pause and have a go at doing this. So let's have a go and see if we can work it out. So first step, we're going to balance the number of atoms for the main species. So I've got 1 chromium atom on the left-hand side, but I've got 2 chromium atoms on the right. So I'm going to need to put a big 2 in front of the Cr3+. I then need to use oxidation states to work out the number of electrons. So if I work out the oxidation state, I've got, if it's 3 plus, then this must be an oxidation state of +3. And on the other side, I've got 7 oxygens, which adds up to -14, because if you remember, oxygen's always -2. It's then got to, the chromium's got to balance it to 2-. So I've got to have 12 coming from +12 coming from the chromium, but there's 2 of them, so each one is going to be +6. This means, so if we have a look at this, we're going from +3 to +6. It's increasing. And if our oxidation state increases, it's being oxidized. This means that each of our chromium ions must be losing 3 electrons, and because there's 2 of them, that's 6 electrons in total. So we're going to need to put 6E- on the right-hand side to show that 6 electrons are being lost. Right, the next step then is to balance the oxygens using water. So just make some space by deleting the bit about the oxidation states, and we can then show adding some water. So if we've got 7 oxygens on the right hand side, I'm going to need to put plus 7 H2O on the left hand side to get 7 oxygens on both sides. I'm then going to have 14 extra hydrogens on the left that I haven't got on the right, so I need to put plus 14 H plus on the right hand side. The final step then is to double check that everything is balanced. So if we double check everything's balanced, so we've got 2 3 pluses on the left hand side, so that's a total of 6 positive charges. And on the right hand side, I've got 2- plus 6E-, so that's 8 negatives and 14 positives. So 14 take away 8 is 6. So I've got 6 positives, and I can therefore say everything's balanced. Let's just write that out nicely in full to show the final thing. So we're going to say that we've got 2 Cr3 plus 7 H2O makes the chromate ion Cr2O7 2 minus plus 6E minus plus 14H plus. Did you guys get it right?